Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the May-June 2018 Pure Mathematics P1. This is from the Cambridge P1 9709. This is paper 1 variant 2. This question is about functions, and it's a question that I put in one of my lessons at the end of it, test your understanding, and it's kind of adapted from this question that I put it there. So I'm going to answer this question that should clarify any doubts that any students might have had with that question that they were asking about. So first of all, it starts off telling us that the function f is defined by f of x is, or f is such that x maps to 7 minus 2x squared minus 12x, for x is an element of all the real numbers. So this is the same as saying f of x equals, it practically is the same thing. Okay. So it says, express this in the form a minus 2 times x plus b all squared, where a and b are constants. So again, we have to complete the square. Now in this case, it's written in a form which we want to rewrite it a little bit. So we can say, let's say f of x is equal to, there's going to be minus 2x squared, minus 12x, and plus 7. Now to complete the square, I want this to say x squared, just 1x squared. So I'm going to take out the negative 2 and write x squared here, but then I have to take out the negative 2 from this, so I have to divide this term by negative 2. That's going to give me positive 6x. Now what I like to do, I like to close the bracket here and then put the plus 7 on the outside. Now, so we're going to have here minus 2, and now I'm going to concentrate on this part in here and complete the square. So I have x plus 3, take half of that coefficient, squared, and then take away the square of this number, which is 9. And then we've got the plus 7 on the outside. Okay, the reason why this is equal to that, if I square this bracket, I'm going to get x squared plus 6x plus 9. Well, I don't want the plus 9, so I'm going to take it away. Now what I'm going to do is I'm going to multiply this bracket by minus 2. And minus 2 times minus 9 is plus 18. Then I've got my plus 27 on the outside. So this is going to be in the form they want it, 18 plus 7, which is 25, minus 2 times x plus 3 squared. So there's the answer for part 1. And part 2, it says state the coordinates of the stationary point on this curve. Okay. So we have now got our equation, or our function, written in complete the square form. Now we're going to go on to the second part. Okay, so for part 2, it says state the coordinates of the stationary point on the curve y equals f of x. So we know f of x is 7 minus 2x squared minus 12x, which we completed the square and put it in this form. Now this is a form from which we can straight away work out the coordinates of the stationary point. Now the stationary point is a place where a curve turns, okay, where the gradient is equal to 0. So we could answer the question using differentiation, all right? However, because we've written it in this form and it says state the coordinates of the stationary point, and it only gives you 1 mark for that, you have to basically just state the fact that the turning point is the vertex, and the vertex is the x value that makes the bracket 0, which is negative 3, and then what's left as the y value, which is 25. Okay, the reason why that is the vertex is because this thing, you're always going to have 25 take away something. You're always going to be taking away something from 25. And this thing here will never be negative because you're going to square whatever's in this bracket. So you'll never get the case where you have 25 minus minus, which will be 25 plus, which means it's going to be more than 25. No, you're always going to be 25 or less. Right now, when is it going to equal 25? Well, when this whole thing becomes 0. What makes this thing 0? When you put x equals negative 2 instead of x. That's when this becomes 0. And you have 25 minus 0, which is a maximum this can ever be. It can't go higher than that. Okay, it's always going to be lower than that or lower. So that's why that's the maximum value. And when x is equal to negative 3, sorry, that's a 3. I put 2 there. When x is equal to negative 3, that's when it's going to reach its minimum point. Okay, its maximum point. So it didn't ask you to tell the nature of the stationary point, just the coordinates. So we can say minus 3 and 25. That's fine. That's your answer. So there's part 2 done. Now for part 3. Now for the actual questions that were asked in the test your understanding. It says, state the smallest value of k for which g has an inverse. Okay, now the function g is a function, as we just mentioned, that has a minimum point. Okay, and if you were to make a little sketch of this, you can see the minimum point is -3 and 25. Okay, -3 and 25 up here somewhere. It's gonna look something like this. It's gonna cross the y-axis at 7. It's gonna go down somewhere over there. We don't need to know anything about where it crosses the axes right now. We just have to worry about the vertex, which is -3 and 25. Now, when a graph has an inverse, okay, is when it's 1-to-1. It has to be 1-to-1. Right now, this is many-to-1. Okay, a many-to-1 function will not have an inverse because when you make the inverse, it will turn into 1-to-many. A 1-to-many function, 1-to-many mapping is not an inverse. So the smallest value of k for which this has an inverse, okay, is the value of k such that this will either be all rising or all falling. So you can either take the part of it when it's going up like this until the vertex, or you can take the part of it from the vertex until from when it falls. So you can't take any part of it that's rising and falling, because when you find the inverse, right now that's going to be again many-to-1, so it'll become 1-to-many. So you have to stop at the vertex. So because they say x, it says state the smallest value of k for which g has an inverse. They've said that g of x is a function which is the same thing as f of x, except the domain is now x is greater than or equal to k. F of x was all real numbers. So g of x is greater than or equal to k, and the smallest value of k for which it has an inverse is going to be right up to the vertex. As long as you go up to the vertex, as long as you don't go past the vertex, you'll be fine. So up to there is fine. Up to there is fine. Let me just... yeah. So it has to be up to vertex, including the vertex, and down like this. Okay, so that's the smallest value of k. So when k is equal to -3. Okay, you can't, if you go any smaller than that, it'll start turning down again, and then you will have a function which is many-to-1. Right now, if you stop here, it's going to be a 1-to-1. Any value further greater than -3 will be fine. We'll give you a 1-to-1 function. So as long as x is greater than or equal to -3, and -3 is the smallest it can possibly be for the inverse to have, so inverse to actually be a function. So it has an inverse, okay, when it's a 1-to-1 function. Many-to-1 functions don't have an inverse. These have inverses. Okay, so there's the answer to part 3. Then it says, for this value of k, find the inverse of g of x. Okay, so the inverse of g of x. So to find the inverse of a function, first of all, let's call it y. So y equals 7 minus 2x squared minus 12x. Now to find the inverse, what we want to do is we want to rewrite this in its complete the square form, which is 25 minus 2 times x plus 3 squared. That's in the completing the square form. Okay, so that's, this was for x is greater than or equal to -3. Okay, so now, when you find the inverse, you take the x and y and you swap them over. You replace the x with y, and you replace the y with x. So when I find the inverse of a quadratic, it's always good for you to complete the square first, and then swap the x and the y. Then you only have one y term to deal with. So now what I'm going to do is I'm going to add this whole term to both sides. So I'll have 2 times y plus 3 squared equals 25 minus x. Then I'm going to divide both sides by 2. So I'll have y plus 3 squared equals 25 minus x over 2. And then I'll take the square root of both sides. So y plus 3 is equal to, now you can either have the positive or negative square root of 25 minus x over 2. Okay, but we can't choose both of them ourselves. Okay, we're going to have to choose one of them. Okay, but I'm going to explain now in a minute which one to choose. So then we have y equals -3 plus or minus the square root of 25 minus x over 2. Now, it can't be both of them. It has to be one of them. Okay. Now, in general, if you have chosen what's to the right of the vertex, then you have basically chosen, or the inverse will be the positive square root. Okay, so that's going to be the positive square root. Okay, if you had chosen what's to the left of the vertex, that means you've chosen the negative square root. Now, if you want to be sure about this, what you can do is you can choose a value of x, okay, and you can see what the original function does. And the original function was y equals 25 minus 2 x plus 3 squared. So we can take the original function, let's say f of x, 25 minus 2 times x plus 3 squared. And let's substitute a value into here. Let's say we put 0 into here. Okay, 0 is a nice easy number to use. If you put 0 into here, you're going to have 25 minus 2 times 3 squared, which is going to be 25 minus, that's going to be 2 times 9, 18. 25 minus 18, which gives us what? 25 minus 18 gives us 7. Okay, now the inverse function, we should be able to take 7 and it will do the reverse. So let's try it in the plus one. You have 25 minus 7 over 2. So you have minus 3 plus the square root of, that's going to be 18 over 2, which is 9, which is minus 3 plus 3, which is 0. So you can see that that's correct. It's taken our the output from the original function, and it took us back to what the input was. So I know that for sure it must be this plus one. It must be this must be our inverse function, okay? And that must be the form of it, all right? Now, if we had, for example, chosen the negative kind of branch, 25 minus 7 over 2, we would have ended up with minus 3 plus minus 3, which would be negative 6. Well, this is going to give us 3, but we'll have to take away that. So we'll end up with negative 6. It does not take us back to the original. So basically, in general, whenever you have had your domain restricted to the right of the vertex, you always take the positive square root of the inverse. If you have got your domain restricted to the left of the inverse, you always take your negative square root of the inverse. And that's basically because of, if you think about the basic y equals x squared, if you have your original function, okay, restricted to the right of the vertex, this is what the inverse will look like, because it's a reflection. But if you had your original function restricted to the left of the vertex, then your inverse function would look like this, because it's a reflection in y equals x. That's a negative square root part. Okay, so that's the same in all cases. So that's how you can work out which one of those to choose as your inverse. You can't have them both, one of them. So we can now say that, and we should really state the domain of our inverse function. Now the domain of the inverse function is the same as the range of our original function. Okay, and the range of our original function is basically y is less than or equal to 25. Okay, so therefore the domain of our inverse function should be the same as that. So we should write here, its domain is x is less than or equal to 25. That's the domain of this function. Okay, and that you can see that makes sense, because when 25 is when x becomes more than 25, then this becomes negative. So it kind of fits in. All right, so x has to be 25 or less for this to be defined. So you can see how that works. It's always good for you if your original function is restricted, especially if they tell you to find the inverse function, you should really state the domain of the inverse function. Even if the question didn't ask you to, it's on the safe side for you to always state it. So that's why I've stated here, my whole answer is this, with the domain x is less than or equal to 25. So that completes this question. Question number, which number was it from this paper? It's number 7 from the paper, and it's also a question from one of my testing understandings from my end of topic worksheets. I hope that was clear. Thank you for watching. Other questions from this particular paper, this exam paper here, when I answer them, will be found in the playlist that should appear in this region over here. Other questions from the topic of, or from the end of topic worksheet on functions, which this is from. Okay, no, actually this is from Test Your Understandings. Any other questions from your Test Your Understandings from chapter 2 on functions can be found over here. Other questions from this topic of functions can be found in the playlist over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon. If you would like to find videos which relate to your syllabus that you're taking, whether it's Edexcel, International A-Level, IGCSE, Cambridge, whatever. If you watch the video, the card of which is being shown from time to time during the video here, you watch that video, click on it, and it will tell you how to find what you need from my channel. Thank you for watching, and see you soon.